Max. I'm the sales engineer of TDS. I'll be your host today, and once again, welcome back to our TDS webinar. Today, we will be talking about industrial robots and vision made easy. On behalf of TDS, I'd like to extend a very warm welcome to all of you. Thank you for allocating your time to attend this webinar. Okay, we will have our Q&A sessions after our last speaker has spoken. So in case any one of you were to forget about your questions, you may just type it in to our chat room, and we will answer it one by one at the end of after our last speaker has spoken. And also a kind reminder to all our audience, I'd like to sing your corporations, okay, by kindly switch off your camera mode and mute your mic in case any unnecessary noise or FaceTime image were to pop up during the webinar. Thank you for your cooperations. Okay. Introduce our new UVC Mobile Robots, okay, which have the technologies to kill virus and germs. Okay, and when the robot is not operating, you may use the top camera as a temperature reading of people going into your office, and it will alert if any of the person detects high in the temperatures. So on the next slide, I'd like to show you a video.
UVC is a proven disinfectant against COVID-19 virus. Introducing IBox, an anti-epidemic robot. Disinfecting your office during after office hours without the need for any human supervision. Scanning temperature of employees during office hours. With 6 UV lamps and a UV power of 180 watts, IBox does a 360 degrees omnidirectional irradiation. Using shortwave UVC, IBox is capable of destroying viruses, DNA and RNA in just minutes. Contact us for more information.
For those who are interested in this UVC robot, kindly just email to our sales and we will give you more information. Okay. And for those who are not familiar with our TDS products, I have displayed up all the brands up here. We are the authorized distributors for all the following brands. So if you have any projects you are unsure of which product to choose, just speak to us directly and we'll guide you slowly in choosing the best product for your best applications. Okay. And for those who have missed our past webinar, not to worry, just subscribe to our TDS YouTube channel and we will upload all our recorded past webinar into our YouTube channel where you can view our past recorded videos. So remember to click on subscribe on our YouTube channel. Okay. So for our next week webinar, we are going back to IIoT topic, Internet of Things. Okay. We are inviting Mr. Aloysius Lim from Mitsubishi Electrics to talk about how smart manufacturing Kaizen level, they call it SMKL, okay, can be utilized for IoT implementations, and also the different types of Mitsubishi product that can be used in IoT implementations. Followed by Taya from TDS will be sharing with us on the overview of HMS Flexi by showing us how to log and transmit data to public clouds and customize dashboards. So be sure to sign up when the registration link is ready. So finally, first, I'd like to invite our first speaker of the day, Branson from OnRobot, to share about their new products. It's not a 2D camera, but it's a 2.5D camera. They call it the ICE. Hi, Branson, are you ready?
Yeah, hi.
Okay, I'm handing over to you now.
Okay.
Thank you.
Sorry, there's some problems with sharing the audio. Give me a second.
All right.
I think there might be some problems with my the audio in the video. I'm not sure what's happening. Give me a second. Hello, hello. Me? Hello.
Hi, Branson. Yes.
Can you hear?
Yes, we can hear you.
Okay, I think there might be some problems with the audio later. If you all can't hear, I'll probably have to play it from another screen. So just let me know later if you can't hear the video itself.
Okay.
Okay, so hi everyone. So I'm Branson from OnRobot. So today we actually we'll talk a little bit on one of our products, which is the vision camera. So this is actually a 2.5D camera. Okay, so I'll talk a little bit on what some of the features of our OnRobot Eyes. We call our vision camera the OnRobot Eyes. So in this presentation content, I'll have a one pager on OnRobot Vision. I'll just share with you OnRobot's vision. And I'll talk a little bit on the value proposition of this OnRobot Eyes. And then, of course, we'll introduce to you the OnRobot Eyes by sharing some of the key specifications. And we understand how to use the eyes. And actually, I'll show, explain on some of the typical applications. And I'll share some demo applications that we did as well with the eyes. Okay, so OnRobot's vision is actually to build a one-stop shop for enabling collaborative applications. So we actually have an extensive range of products that we want to cover all robots, all applications, all accessory types, and inside all the industries. Okay, so OnRobot will enable you to actually build highly versatile robotics solutions. So the vision of OnRobot is actually to build a one-stop shop for all of your collaborative needs. Okay, so moving down to the value propositions of the OnRobot Eyes. So as you know, adding visions to robotic applications, some of the vision camera can be quite complicating. So for OnRobot, we actually try to make it easy with our one picture calibration, fast programming, and seamless gripper integration with any of our OnRobot grippers as well. So it's flexible and adaptable vision system with robot mount or external mounting is also possible. So it's very ideal for almost any collaborative applications. So it's also quite affordable and efficient 2.5D visions. So the 0.5D we offer actually the depth perception for varying heights or stacked objects. So I'll cover a little bit on what is 2.5D actually. So you can also easily sort and pick and place unstructured applications with high reliability using any of the supported brands that OnRobot is actually supporting. Okay, some of the product features of the OnRobot Eyes. So everything is actually done through, all the teaching of the eyes is actually done through our web client. So if you're not familiar with web client, it's actually an IP-based software from OnRobot. So you just need to actually connect the IBox, as you can see at the bottom side of the picture, the IBox connected to the computer and you can hook it up. Okay, so the OnRobot comes with an IBox. Like you see, this is a set here. It's integrated with all the brands of robots that we are supporting. Total, we have I think 11 brands of support of robots that we are supporting. Two different kind of mountings is available: external and robot mount. So some of the key specifications, I will not go through every single one. If you need more information, you can actually approach TDS or you can actually go to our website, onrobot.com, to download the data sheets. Okay, so the image sensor technology, we're actually using rolling shutter. The depth technology, we are using active IR. And the working distance of the camera, it's from 400 mm up to 1 meter from the top of your workpiece. Okay. The IP rating of the camera is IP54. So as mentioned, this is actually a 2.5D camera. Okay, so the minimum part size detection is 10 × 10 mm or 15 mm in diameter. Okay, so we support two different kind of mountings, robot side and external as well. And the reconfigurability, when it's robot mounted, we have two different kind of configurations. Okay, rotation around the robot flange, we have 4 different angles, and tilt angle as well. And for external mount, we have just the tilt angle. Okay, the processing time is typically around 0.5 seconds, so it's pretty fast. Okay, and the detection repeatability and the accuracy is about 2 mm. So applications and setup recommendations. Of course, for lighting conditions, we recommend no drastic or instant changes for the lightings, and also keep minimal all the reflections and the focus light spots. And of course, the characteristics of objects, it is best to be different from the background. And the camera, with respect to the workspace table, it is best to have the camera looking straight at the surface, but of course it's also possible to be looking it at a tilted angle as well. Okay, so just to explain a little bit layman terms on what the difference, what is 2.5D. So I actually got this particular information from Google itself. So those who are not familiar, for 2D, this is actually how the camera can detect just by the X and the Y axis and the rotation Z axis. Okay, and for 3D, of course, you have all 6 axes to actually detect. So even if your parts are tilting in the RX and RY direction, you can also do a detection. But for on-robot eyes, we are somewhere in the middle. Okay, we have the X and Y and the rotation Z, and as well as the Z axis direction. So we can actually detect the depth of the workpiece as well. Okay, so this is actually layman terms on the differences between 2D, 2.5D, and 3D. Okay, so the IBox, what is actually the IBox? So the IBox is actually the controller for the on-robot eyes. It contains all the features of our compute box. So a compute box is actually another controller for our other robot brands. For our other products as well. So it's pretty much similar, except that the IBox has to be used together with the eyes. Other on-robot devices can also connect together with the IBox, which means if you have our on-robot eyes connected together with any of our grippers, you just need one particular controller. Okay, so for any robot, the setup and programming of the eyes is all done via the web client. So we support 3 different communication protocols: Ethernet IP, Modbus TCP, as well as digital I/O if you need it for our grippers as well. And of course, the power supply is 24 volts. Okay, so as I mentioned, there's 2 different kind of mountings. Okay, as you can see, this particular bottom left side picture, this is the eyes on the robot mount. Okay, so the flange is the number 5. So you actually mount the robot mount to the flange directly. And then if you want to use any of our on-robot grippers, you will need the additional quick changer just below the on-robot eyes. And if you want to do it via external, it is also very simple. All you need to do is just to remove the bracket for the robot mount and just install the external mounting bracket, which is provided as well in the whole package, and just mount it onto whichever area which is suitable. Okay, so you can also combine a dual setup, which means 2 grippers as well together with the eyes with our dual quick changer. Okay, so as mentioned, you have 2 different kind of configurations, the tilt angle and the rotation angle. Okay, so this is roughly how it would look on the eyes itself. So if you want to tilt the camera itself, you have 3 different angles, 0, 45, and 90. And for the rotation, you have 4 different angles, as you can see over here. So how to connect the on-robot eyes? It's pretty much quite simple. Just one cable, a USB cable from the eyes direct to the IBox. As you can see, we have a USB port over here. And if you want to connect, combine it with any of our gripper as well, just connect another device cable from the quick changer to the IBox. So it's very, very easy in installation-wise. So for the kind of typical applications that can be used with the on-robot eyes, of course, material handling. So you can actually locate items for palletizing. You can detect parts for actually packaging as well. You can use to find objects for transferring materials from and onto conveyor. We'll have a short video on that using the UR's conveyor tracking program. You can also do sortings of different work pieces as well. And of course, you can use it for machine tending as well. Locate the parts for transferring to further machining, detecting finished parts for transferring from end machining as well. And of course, can sort different work pieces to be placed into different machining operations. So these are the kind of different typical applications that you can actually use our OnRobot eyes on. Of course, there are more types of applications that can be used depending on how you want to make use of it. Okay, so the OnRobot web client. So I will share a video. So this video will actually show you how to do a setup of the OnRobot eyes, how easy it is to actually implement the teaching onto the robot program itself. I think there is some problems with the video. Let me just play the actual video. Just give me a second. Sorry about the technical issues over here. Let me share the actual video. Just give me 1 minute. Can you guys see the screen?
Yes, Branson, we can see.
Can you hear the sound?
Sound, I don't think so. No.
There's no sound?
No.
Okay, sorry, just give me a second.
No sound.
Can you hear the sound now?
Yes, Branson.
Okay.
Thank you.
So this video will actually show you how to actually do a setup on our OnRobot eyes. So very simple. All you need to do is connect our IBox to our laptop and key in the IP address of the IBox. And once you're inside, you can actually see this particular screen. So what I have connected is our OnRobot eyes, our RG2. So all the teaching will be done through the OnRobot eyes. Okay, inside the OnRobot eyes, there's 4 settings here to complete the teaching. So in the first thing, we actually go to our settings, and of course, we will check which robot we are using. As of now, I'm using the UR. We have 2 different kind of mountings. As of now, I'm using the robot mount. And for the rotation and tilt angle, you have to check physically on the mounting itself, what is the angle and the tilt angle. So I'm using 0 degrees and 90 degrees. So once this is done, just save it and it's saved. So we'll go into the camera view. So to add a camera view, make sure you position a robot with in respect the distance with the specs 400 mm to 1 meter. So we click on the camera view and you insert your calibration plate inside. So you can play around with the color exposure and the color white balance. So if you feel that it's too bright or too dark, you can play around with it. For example, like this. And you can maybe make it whiter in a sense. So something like this. And if you feel this is okay, I think this is quite a good color. So it's next. And after that, we'll just remove the calibration plate. And once that is done, click next. So we just set a camera view name. So for example, I'll just put OnRobot and save. Okay, so that is done. So the first step is the camera view, very straightforward, and then it's done. So next, we actually teach a workpiece. So as you can see, I'll click add a workpiece. I'll select the camera view, which I have set earlier with the robot position, which I have set on robot. Okay, so as you can see over here, this is the field of view of the camera. So I'm going to place the workpiece inside the field of view. Okay, so as of now, I'm using 3 stack cubes over here. So later in the video, you can actually see. So I have 3 exact same workpieces with the stacked on top of each other. So just to show you that I can just teach one particular workpiece, and the OnRobot eyes, the 2.5D vision with the Z depth perception, I'm able to actually do destacking of the workpiece. So I have a region of interest here. So what this does is, if I have multiple workpieces inside here, I can actually narrow down. As you can see over here, I can narrow down to whichever workpiece I want it to detect, and I can actually do a detection over here. But this is actually not the place only where the vision system will actually detect. This is just to set the workpiece. So we can actually do some adjustments on the lightings to see if it's if the lighting system is the lighting is not too good. We can actually adjust it. But as of now, you can see a very nice detection point over here. So we can also play around with the height limit over here. So you see, if it's too high, it will not actually detect anything. So I'll probably just set it around just around 8 mm to 6 mm. So this will actually, because I cannot set it higher than the last workpiece. So the height of each workpiece is around 15 mm. So I'll probably just set around 6 mm, and it's okay. So it will be able to pick up the last workpiece as well. So next, we need to set the symmetry. So of course, this is a cube, so I will set it as a square symmetry, and that will be done. And after that, I'll just set the workpiece name. So I'll put stacked workpieces, for example. So that is done, and I'll save it. Okay, so you can add on multiple workpieces in the same camera view. It is not an issue. But as for an example, due to time constraint, I'll just show you one workpiece and how we can do destacking with just one workpiece settings. Okay, and finally, we will do a program. So I add a program over here. And for the method, as of now, we only have one method, which is the object-based detector enhanced with depth data. So this is the only one that we have, and we create a program name. So I'll just put OnRobot. Once that's done, I'll choose the camera view, which is OnRobot, which we have set earlier. Okay, so as you can see now, this is the yellow region of interest is the area where the camera will detect my workpiece. So at the bottom here, I need to add my workpiece, which is the stacked workpieces. So you can see now, the camera actually detects the workpiece. So I can actually adjust the detection area as well. So I can just put it over here like that. Okay, I can adjust it here. So every time when the camera runs this particular OnRobot program, it will only detect within this area, although the field of view is this big. Okay, so there's a few options for you to actually use. First option is the use fixed height. So this, if you check this option, it means that the Z reference will always be on the surface. And of course, we have another one, which is color. So if you have exact three different workpieces, the exact same size, but all of them different colors, you need to add 3 different workpieces with different names, of course. And from there, at the bottom here, you can actually add all 3 of them, and you click the color, and you will all separate into 3 different workpieces. So this is how you actually differentiate color. And the next option you have is the priority. So in here, we have actually 4 different priorities to choose, which workpiece you will actually pick first: top to bottom, bottom to top, left to right, and right to left. So as of now, we only have one workpiece, so it doesn't really matter which sequence I choose. So I just leave it as the first one. And we also have the fine-tune detection over here, as you can see. So just leave it as per normal, as default, as it is having a good detection point. So next is this particular offset over here that we have. These are the options. So you can actually adjust how you want the gripper to pick. For example, now if you see the red is the X offset. So now my gripper, my 2-finger grippers will be actually picking from this direction. So if I wanted to move to pick it in this direction instead, I can actually play around with the rotation Z. So for example, I can put 90 degrees, and you can see now my pickup point will be here. And depending on where the gripper's y-axis is, you can play around it. You can put it to be 90 degrees if you want it to be the other side, minus 90, I'm sorry, or positive 90. So it'll be this side. Okay. And for the X, Y, and Z offset, I'm sorry, and if you want the gripper to tilt while picking, you can play around with the rotation X and the rotation Y as well. So it will be, the gripper will actually pick the cubes when the gripper is slanted in a sense. But as of now, if I leave it 0, it will be direct down from the top. And I have this particular Z offset as well. Okay, so what does this Z offset do? So when we run the program, sometimes the robot might not be able to reach the workpiece, maybe due to some leveling issues. So from here, we can actually play around with the Z offset. I can make it higher or lower depending on how your pickup will be. So you need to test it out on the program itself before you can do some fine tuning in the settings. And for the X and Y as well, is also the same thing. For example, now my pickup point is dead down in the center. And if, for example, I have an irregular shaped workpiece, I want to shift my workpiece, shift the pickup point to outside, I can actually play around with the X and Y. So for example, if I shift it to 10 mm, you can see it moves to the side. And my Y, for example, I shift it to another 10 mm, it moves. So you need to play around with the robot, run the program and see how is your pickup point. And from there, you can actually do your offsets over here. Okay, so this is actually how you do simple programming. So once this is done, just save it and the program is done. And in the UR itself, once you start your program in the UR cap, all you need to do is just to call out the robot, the program name, which we have saved as, let me see, OnRobot over here. So you just call out this particular name. And if you're using any brand of robots outside of UR that we are supporting, you need to call out this numeric ID. Okay, so this is actually how you do a setup on the OnRobot eyes. I hope you have a good understanding on this. This is just a very simple setup due to time constraint. Okay. Okay, so sorry, just let me share back my the other screen. Give me a second. Okay, so I have another video which I mentioned that we can actually use the UR's conveyor tracking function to actually do some packing. So this is the application video. I don't think there will be any sound in the background due to the technical issues that we have, but you can actually just take a look at the video. So at the start of the video, the angle is a little bit weird, but later on, a few seconds later, it will actually change back. So just, it's not, I'm sorry, there's some problems with the video that doesn't play. Give me just 1 minute. I'll see if I can settle this problem. Okay, can you guys see the screen now?
Hi, Branson. Yes.
Yeah, okay. Sorry about all the problems. I think now it's okay.
Yeah.
Okay, so I'll just play the video now. I think it's working now with the sound. Okay, so just see this is a very, very short video. Okay, so just to explain a little bit. So as we are using the conveyor tracking from the UARS program itself. So what we did was it will actually detect the sensor at the start of the conveyor, and once it's detected, the OnRobot eyes will start to search for the workpiece, and after that it will actually follow the workpiece and then pick it up with our 3-finger gripper. So it's very ideal for cylindrical workpieces. Okay, so that's the end of my presentation. I hope you guys have better understanding on the OnRobot eyes, and of course we will actually take your questions later on after the next presenter. So thank you once again for your time. Hand over to you, Max.
Hi, Branson. Thank you for your presentations. Next, I'd like to welcome Aloysius from ABB Robotics to share with us industry robots and robot software on how to boost productivities and applications. Hi, Aloysius. I'm heading over to you now. Hi, Aloysius. We can't hear you. I think you need to unmute yourself.
Yeah. Thanks, Max.
Okay, you may carry on. Thank you.
Okay. Yeah. Thanks for having me, TDS. So today I will share on ABB Robotics and talk a little bit about the developments in different industries for robotics. So as a short content, I will have a short introduction on ABB Robotics. I will talk about the developments that robotics industry are doing among different industries, and also specifically on 3D bin picking. So what kind of potential applications are there for 3D bin picking, and which industries can actually benefit from this? After that, I will talk about 3D printing and also a little bit on additive manufacturing for robotics. So how 3D printing can be made easy with ABB Robot Studio, which is a software from ABB. So which industries can benefit from 3D printing, and also some examples. So a little bit on ABB Robotics. We are European robotics company, and we have sold about 400,000 robots globally. So there are about 400,000 robots of install base globally. So we are in 53 countries in more than 100 locations. And these are certain industries which you will be very common to see robots, especially in the first row. So of course, the top market would be automotive. So automotive is where robotics actually started. If you see any automotive company, you will most likely definitely see robot applications. And foundries, so robots are used in high temperatures, metal fabrication like robotic welding, machining also. So some metal industries where this robotics application has been common throughout the years, and also CNC machining to do machine tending, as well as plastic industry where you see robots doing machine tending for injection molding. So over the years, robots have been developed to many other models and also entering different markets. So some examples are F&B, medical, logistics, and electronics. So I will start off with a video on 3D bin picking to have a quick illustration on what was it like. Yeah, so as you can see, actually the robot are picking those bottles, and the bottles are not arranged so accurately or so nicely. They are actually just thrown into the bin, and thanks to 3D bin picking with the Pickit 3D camera, the robot is able to identify which is actually the site to pick. So where are some applications where this can be applied into real applications? So 3D bin picking can be very common in logistics, in automotive, and many other industries. So application-wise, actually palletizing are often used with the same carton box. But with 3D vision, we can actually do mixed palletizing. This is one example of mixed palletizing using 3D vision. So yeah, this is an example of 3D vision palletizing. So instead of showing something which is often used in manufacturing, like mixed palletizing of carton box, I decided to show this video because it's rather interesting. So different luggages definitely have different sizes. And with the help of 3D vision, this is an example of 3D vision palletizing. So where are areas or industries that can actually benefit from this kind of systems, like 3D vision? So what you see in the picture here is an ASRS system. So e-commerce and logistic warehouse, it's a big market, definitely a big one in upcoming years. They are growing, especially in this period during the pandemic period. So what you see in the picture is an ASRS. So it's actually a big shelf or a big storeroom for companies like Amazon and Lazada. It's a big automated shelf system where the companies store their products and it moves around very efficiently. So the next process, however, it's where the items come down and they will place it from the totes into a carton box. And generally, it will be done by operators. So they have to do that the entire day. The operator will actually pick the part into the carton box once every 4 to 5 seconds. So companies like Amazon and Lazada have to hire people to do it all around the clock. Yep. So e-commerce companies actually spend a lot of money, like almost millions, on human pickers. So this is one area where it's a big market for 3D vision. So other industries like automotive, as shared, automotive is one of the most automated industries. Every 10 employees, there is actually one robot in automotive industries. However, there are still a lot of applications like machining, where you can actually introduce 3D bin picking, like the one shown in the left picture. General electronics manufacturing. So these are less automated. Generally, whenever you see a PCB board or a wire or a tube, these are items which are more difficult to automate in common products. So with 3D bin picking, there is actually a good chance to automate certain processes. In today's general manufacturing, every 200 employees, there is about one robot in general manufacturing. So we also have industries like textile manufacturing, where you will almost, it's hard to automate. So generally, these are items like cloth and fabric. These are not so automation friendly materials. Yeah. So one area of development is also in food manufacturing. So development in robotics, like food grade robots, are very widely used today in food manufacturing, where we actually need to directly handle the food. Yeah. So in areas like 3D vision, this is also extremely helpful. Reason is if you're picking, say, like a chicken nugget, but every chicken nugget may come in different forms. Yeah. So last but not least, I will talk a little bit about the construction industry. So this is also another industry which is very little automated, and based on our feedback also from our existing customers, construction industry is one of the fastest growing and also in need of automation help. So one example is robotics for 3D printing and additive manufacturing. So what you can see in the two images below, it's an example of how it looks like. So the overall market size is actually having good growth in this industry. It's one of the fastest growing segment in manufacturing. So we can also leverage on existing products for 3D printing technology, such as dispensing and certain processes which really currently are using. So based on very clear client feedback, we believe that this is one of the areas, and also ABB Robotics is exploring, and it's mostly untouched by other robot manufacturers. So this is a video that illustrates. Okay, so an overview of what 3D printing is, especially with the help of ABB Robot Studio. We want to make 3D printing with robots easy. So an overview of what the Robot Studio 3D printing is, it generates rapid code. So rapid code is ABB robot program language from a G code. So these are traditionally used in small 3D printers. So if let's say you want to 3D print something, generally people will look for 3D printers. However, there are certain limitations such as product size. So with 3D printing using robots, there is actually no limit in product size and also no limit in the number of coordinate points. So if let's say you're printing something very large, you need the help with also ABB track and also positioners example. This can be supported for external axis. So general flow of how 3D printing is done. So from a 3D CAD file, we don't actually teach the point. Yeah, if a customer have a 3D CAD file, they will convert the 3D CAD file to G codes. This can be done using a third-party software or slicer software, and then it will be input into ABB software, which is 3D printing power pack. So what it does is it converts the G code into robot language, and we are able to generate a simulation. So we definitely encourage and advise customer to do a simulation. This is because the robot is able to identify the reachability, whether it can reach and 3D print all the locations and reach all the location. And also it allows you to know the cycle time of how fast it can be printed. So from the ABB robot program, it can convert into a simulation. And once you're happy with the simulation, you can run production. Yeah, so this is how a simulation will look like on the left video. So due to time constraint, I will not play the whole video. This on the right, it's the actual robot doing the 3D printing, which will simulate the one on the left in the actual production. So as an overview to emphasize, Robot Studio allows simulation of the actual application before you actually purchase the robot. So it largely reduces the risk of the project, and so it ensures the reachability and the cycle time. So this is some success cases. So I will share some application. This is a company in Sweden. So they 3D print concrete bridges, which are up to 30-meter long and also into 150 different segments. So without 3D printing software, they might take up to days to produce a part. But with the introduction of robotics to do 3D printing, and as well as ABB Robot Studio, they are able to print a segment in less than 30 minutes. Some examples like this is also a fun one. So ABB Robotics are also printing kayaks. And this company is also a Swedish company. They have a strong team of designers, and they create very, very unique and very funky kind of furnitures. And they use robots to 3D print them. So last but not least, I'll share a little bit on additive manufacturing. This is pretty new, and maybe you can take a look at the video first. Yeah, so apart from 3D printing concrete and also polymers, this is 3D metal printing. The one to show in the video is actually using welding technology to 3D print metal objects. Yep, so this can be something that is used in aerospace industry and also oil and gas. So as a summary, with the developments in 3D cameras, in sensors, and also robotics, many applications which were once thought not possible to be automated today can be made possible. So with the help of all these developments, robotics has outgrown common pick and place and very repetitive tasks. So today we are handling more difficult and more dynamic applications. This will only become more common. This is also because in current products, life cycle can be quite short. Yep. So for 3D bin picking, it can be very helpful in many industries like logistic and e-commerce, precision industries, and also food manufacturing. ABB has also developed a 3D printing power pack on our software, Robot Studio, to simplify 3D printing applications. 3D printing is also one of the fastest growing segment in manufacturing. This can be very common in construction industries. I have come to the end of my presentation. Thank you very much for listening. I'll pass back to you, Max.
Hi, thank you, Aloysius, for your presentations.
Thank you.
Okay, it's time for Q&A sessions. So if anyone has any questions, you may just type it in the chat room, and our speakers will reply to you. Okay, I think we have a first questions for OnRobot. Hi, Branson, are you there? Someone is asking if your OnRobot eyes can be used for outdoor applications.
Okay, so ideally, we don't really recommend outdoor. I mean, the most logical reason is because of the lightings. It might be possible with an external lighting, but I mean, everything is, you have to try it out. But of course, if you are using just the lights from the outdoor, it ideally is not really recommended because there's always changes within the lights outdoor. So you might be able to detect parts at certain angle, certain area, and probably when you shift it to another area, you can't really detect it because of the lightings. So, but like I mentioned, it might be possible if you have an external lighting system somewhere which can shine a more consistent light onto the surface. So I will not totally rule it out, but it's also down for testing.
Okay, thank you, Branson. Another question is for you as well. Okay, how does OnRobot EOAT integrates with ABB Robots? I think that is end of effector, right?
Yeah, end of arm toolings.
Okay, so it's end effectors. Okay, yes.
Okay, so ABB is also one of our supported brands of OnRobot. So our grippers are also fully integrated together with ABB Robots. Even our eyes can be used on the ABB. So everything is done via Ethernet IP. So, but of course, if the users do not want to purchase, for example, the Ethernet IP package from ABB itself, there is a cheaper option to actually use our grippers. You can use it via digital I/O. That is also possible. But if you're talking about the OnRobot eyes, digital I/O is actually not possible at all. So you only can use it via Ethernet IP on ABB itself.
Okay, thank you, Branson. So is there any more questions from the audience? Okay, I think there's no more questions already. If not, thank you very much, ladies and gentlemen. We have come to an end end of our webinar. Thank you very much for your participants, and I'd like to thank you all speakers for your presentations. And I hope the audience will enjoy the program that we have provided. So if anyone will have any further questions or inquiry, do just drop us email and we'll approach to you individually. Okay, thank you and see you on our next week webinar. Thank you.
Thank you.
Thank you.
Okay, thank you. Bye bye.
Thanks for having me. Bye bye.
Yep, see you soon.